Today we are going to look at simplifying square roots. You will use this topic inside the quadratic formula, so that's why we're going to talk about it. The Apex website you guys use does show you one way to solve it. I'm going to show you guys another way that is better for my visual learners. So I have 3 steps. Step 1, create the factor tree. Step 2, identify any pairs. Step 3, the pairs go on the outside, the singles stay inside the square root symbol. So my first example I have is the square root of 12. So what I'm going to do is create a little tree. I'm going to take any 2 numbers that multiply and equal 12. So I know right away 3 times 4 is 12. If you wanted to use 6 and 2, that would work also. You will end up with the same final answer. So if I look 3 right here, I can't divide that by anything else. So 3 is prime. We're going to stop there. Next, I'm moving over to the 4. If I think about 4, I can divide that one. So I'm going to break that down into 2 times 2. So when you're creating your factor tree, the numbers at the end should be prime numbers. And prime means they're only divisible by 1 and itself. So I broke my 12 down into the prime factors. Now I'm going to look at the pairs. Right here, I have a pair of 2's. So as soon as I see a pair, that tells me the 2 is going to be on the outside of my square root in my final answer. And if you notice, I only put 1 2 on the outside. So by taking out a 2, by putting the 2 on the outside, we're actually taking out the square root of 4. And 4 is a perfect square, so that's where the 2 comes from. Now this 3, that is a single 3, so it stays inside. So my final answer, let's write this a little bit nicer. We have 2 times the square root of 3. So let's take a look at one more example. And let's do the square root of 48. So I'm going to start this the same way. I'm going to list any 2 numbers that multiply to equal 48. So I know 6 times 8 is 48. And again, you can use whatever 2 numbers you want here as long as they multiply to equal 48. So now I'm going to look at each one of my numbers separately and continue breaking them down to the prime numbers. So with 6, I can divide that by 2 and 3. 2 and 3 are both prime, so I am done with that side. So go back to my 8. I know 2 times 4 is 8. 2 is prime, so I'm going to move over to the 4 and continue breaking that one down. So I want to look at just the ends of the factor tree. So if you want, you can even cross these out just to make sure you're only focusing on the numbers at the very end of the tree. So I have, let's highlight these. I got a 2, 3, 2, 2, and 2. Those are the numbers I want to use to figure out what numbers go on the outside and what numbers stay inside. So I want to look for pairs. So right here I see a pair of 2's, and then I have another pair of 2's right here. So from this pair, I get 1 2 on the outside. Then I have a second pair, so I'm going to put another 2 on the outside, and I'm going to multiply those 2 together. Now if I look, I have this single 3 left over. That 3 is going to stay inside my square root because you can only leave the square root symbol if you have a buddy. It's just like when you go camping. You can only leave the tent if you have a buddy. So I'm just going to simplify this, write it a little bit nicer. So the square root of 48 simplified is 4 times the square root of 3. Let's take a look at just one more example that's a little bit different. And let's take a look at the square root of 64. So for my square root of 64, again, I want to figure out what 2 numbers multiply to equal 64. Now this number is a little bit bigger, so let's say it's an even number, so that means I can divide it by 2. So 2 times what gives you 64, and that would be a 32. So again, 2 is prime. I'm done with that branch of the tree, and now I'm going to break down that 32. So again, I'm just going to divide these by 2. So 2 times 16 is 32. Break down my 16. I can do 2 and 8. Break down the 8. We got 2 and 4. And then I break down the 4 into 2 times 2. So this tree is a little bit bigger, so we might want to cross out the extra numbers that I have. So as soon as you create this little tree, let me change color for you guys. As soon as I create this branch, I'm done with that number. So I'm not using the 32, I'm not using the 16, I'm not using the 8, and I'm not using the 4. So we just want to focus on the very ends of my factor tree. So I got a lot of 2's here, so I want to organize this and figure out how many pairs of 2's I have. So I have one pair of 2's right here. I have a second pair of 2's, and I have a third pair of 2's. So I get 1, 2 from this group, 1, 2 times from this group, and 1, 2 from this group. And if I look, I used all of my numbers in my factor tree. So that means there will be no number left inside the square root sign. So I don't need to write that square root symbol at all. So all I have to do from here is simplify my 2's. So 2 times 2 times 2 is just 8. So some of you guys might have noticed at the very beginning, this 64 is a perfect square because 8 squared equals 64. So you can either recognize that 64 is a perfect square and say that the square root of 64 is just 8, or you can actually show the math and create this factor tree to show it equals 8. So the only time you have no square root sign like that is when you have no single numbers left inside the factor tree, or when you have a perfect square. So hopefully this helps you guys simplifying square roots.